Hi, this is pre-calculus video on solving log and exponential equations. So the first two problems are review. I'd like you to take a look from last class, see if you can do them. Basically see if you can change the bases and then press pause and then try them. Okay, so now that you've tried them, you'll notice we've got a base. If I move this 16 over to the right in an equation, and I change the base of this to be 4. So I rewrite 16 as 4 squared. Now I have 4 to an exponent equals 4 to an exponent. Well, that just means those exponents can be set equal to each other. So we can just drop that base altogether. So I can set the exponent 2x minus 1 equal to the exponent 2 and then just solve for x. Same for b. If I move 27 to the x to the right, I notice that 27 is 3 cubed and 9 is 3 squared. I'll just rewrite 9 as 3 squared and 27 is 3 cubed. And now if you've got an exponent, if you've got 3 squared to the 3 minus x, you need to multiply those exponents, and that is a property from Algebra 1. And those need to be distributed. So this is 2 times 3, and then you have to multiply the 2 times the negative x. Ooh, that's really messy. But you'll get 2 times 3 is 6, and then minus 2 times x. So you get 6 minus 2x for the exponent. And on the right, you get 3x. We'll just set those exponents equal to each other right here and solve for x. Okay? So if you get an equation where you can change the base to be the same as the other term, then you can just set the exponents equal to each other. So that's the first example. The second one, example 2, now you're solving exponentials when the base cannot be rewritten like we just did. Okay, so don't worry about b yet. I wish I could. Let me pause. All right, perfect. So first thing I'm going to do is throw this 27 over to the other side. And if I rewrite this as, and I don't have a lot of space, and this is several steps, so I'm going to try to write small. 4 to the 2x minus 1 equals 27. I notice I can't rewrite 27, as a base of 4 or 4 is, or even as a base of 2. So what I can do is I can just log both sides. And I think the easiest way to do that is to do natural log of both sides. And the way we write natural log in regular handwriting is with a cursive L, just so everyone understands. I mean, you don't have to, but it's just so everyone can see that's L and not a 1, because sometimes if you write LN like this, people think it's a 1. So I just write a cursive L. So natural log both sides, because if you do that, now we can use those log properties and take this exponent and throw it in front. Okay, so I'll go ahead and do that. So the exponent in front ends up becoming 2x minus 1 times the natural log of 4, which is a number, okay, equals natural log of 27, which is a number. Well, now, what are we trying to do? We're trying to isolate the x. So let's go ahead and distribute this natural log of 4, because if you had 2x minus 1 times some number like, I don't know, like a 3, you would be distributing the 3. We're going to do that with the natural log of 4, because the natural log of 4 is a number. So I'll go ahead and do that. So I'm going to rewrite this as 2x natural log of 4 minus 1 times the natural log of 4 is just the natural log of 4 equals natural log of 27. Now I'm getting closer. I've got to isolate that x. So I'm going to move that natural log of 4 to the other side, and then I'm going to divide both sides by everything but x. Okay, just solving the equation like it's Algebra 1. Okay, so if I move the natural log of 4 to the other side, I'm just adding it. I get 2x natural log of 4 equals natural log of 27 plus natural log of 4. And then I'm going to divide everything, both sides, by everything but x. All of x's friends. 2 times the natural log of 4. 2 times the natural log of 4. So all I really need to do now to get x is type all this stuff into my calculator. And if you do that correctly, you should get approximately 1.689. So I'm going to come over to the calculator. Come on. Why is this not working? All right, now I have to put two terms in the numerator, so I'm going to use alpha y equals and numerator over denominator because that's just, it's my favorite to use if I'm writing a fraction, because I don't have to worry about a parentheses in the numerator and a parentheses in the denominator, which we had to do before we had this function on the calculator. Natural log of 27, close parentheses, what else is in the numerator? Plus natural log of 4. Let the calculator do your work for you. Over. Now, when you put the stuff in the denominator, you've got, if you're not using this function, you have to make sure you put a parentheses around the denominator. Here you don't really have to because the calculator knows because it's set up as a fraction anyway. But just be careful because you've got to tell the calculator that you're dividing by both the 2 and the natural log of what is it? 4. I'm looking at that. I'm like, oh, is that a 21? No, it's a natural log. All right, enter. All right, so I got 1.688, and the number after the 8 was a 7, and so I rounded up to a 9. So that's where I got this answer. All right, see if you can try the next one on your own. Press pause, and then I'll show you the answer. Okay, so if you natural log both sides, and then take the exponent and throw it in front, both exponents, actually there's an exponent on both sides this time, and then distribute the natural log of 5 to the 3x and to the 1, you get 3x natural log of 5 minus 1 times the natural log of 5 equals 4x natural log of 7. Okay, at this point you're like, all right, what are we doing again? We're isolating x. Currently, we've got a term here with an x and a term here with an x. We've got to get all those terms with the x's together and then factor the x out. So everything without an x goes on the left, which in the next step is negative natural log of 5. Everything with an x goes on the right. So I subtracted 3x ln of 5 to the right. Okay, so that's how I got this term. Now, I'm just going to factor out the x. Once I do that, the x is almost by itself. Now it's being multiplied by all this other junk that I have to divide both sides by. So then I divide both sides by that same number, and our x is isolated. You throw all this into your calculator, and make sure you do it right, order of operations, and you should get x is approximately negative 0.0545. And this is algebra. I mean, the algebra is not, it's all the same properties that you learned in Algebra 1 and Algebra 2. It just gets a little bit trickier because we've got natural logs and sines and cosines, but it's no different. And you've really got to have a strong foundation in algebra in order to do well in pre-calculus and also calculus. In calculus, you've got to, all we're doing here is just manipulating stuff to look the way we want it to look, depending on the problem. So let's go ahead and go to example 3. See if you can try it, press pause. So it says rewriting the logarithm as an exponent. All right, well, why don't we, shoot, I'm losing my pen here. Write it as an exponent. 2 to the 4th power equals x plus 4. Well, now I'm like, all right, well, what do I do now? I'm solving for x. I got to get x by itself. So I need to end up subtracting this 4 and bringing it to the other side. And that's how I end up getting, excuse me, x is 12. All right, let's move on to example 4. Okay, so we're using condensing properties to solve. All right, well, we need our answer to look like x equals something, okay? And currently x is inside these functions. So we're going to have to get it out of the function. But before we can do that, and the only way we're going to do that is rewrite these logarithms as exponentials, but we've got to get these together. But notice these logs are the same base. So we can use those log properties. Same base means multiply, right? So let's see. What did we do? Oh, sorry. So the log of base 3 and that's going to be x times 5x minus 12, just using the log properties. And that's going to be what? 5x squared minus 12x, just multiplying, equals 2. Well, now I've got one logarithm that I can rewrite as an exponential. So I'm going to go ahead and do that. 3 squared equals 5x squared minus 12x. The reason I rewrote it as an exponential is because we are solving for x, and currently that x is inside another function. We've got to get it out of that function before we can isolate it. And the only way we can get it out is by rewriting that logarithm as an exponential. So I did that, and now I've just got to solve. So I'm going to throw my 3 squared to the other side and see if I can factor. Hopefully I can factor, because if I can't factor, then I'm stuck doing quadratic formula or completing the square, which we haven't done yet this year, but you did it last year and you probably don't remember it, and that's fine. All right, but look, I just did this the other day. That's a prime number, so that's got to be 5 and 1. 9, that's either 3 and 3 or 1 and 9. So let's do guess and check here for factoring. Put our parentheses, 5x and x. One's got to be minus and one's got to be plus. So, just try something. I'm going to try 3 and 3. Let's see. So I know that my first terms are going to work. 5x times x, that's going to be 5x squared. And I also know I've set this up to my last terms are going to work. However, are the inner and outer terms going to work is really the question. So here is the outer and here is the inner. And if it doesn't work, then you got to finagle things and change the 3's to a 1 and a 9, or change these pluses and minus and flip them around. Because right now, I haven't checked it. I don't know if that's a plus or a minus. I just guessed. I could have put the minus just as easily right here and the plus here, because I don't know which is which. All right, so the outer is negative 5x times negative 3, negative 15, plus 3. Hey, I did it right the first time. So that ends up being x equals 3, and x equals, this is negative 3/5. So basically, I just set each of these equal to 0 and solved, because that's equal to 0. So that means whatever I put in here is going to make this factor equal to 0. And then it doesn't even matter what this factor is, because 0 times anything will give you 0. And same for this one. If I throw a 3 in here, it doesn't even matter what the value of the other factor is going to be, because 0 times whatever this number is going to be 0. So 3 works, and then negative 3/5. Well, now I got to make sure these numbers even work, because right away I'm thinking negative 3/5, and I know that's super messy. I can't put negative 3/5 in here, because as we discussed earlier, we cannot have, like, if I rewrite the log of some base, to a number like 2 squared is 4, this number, there's no way we're going to be able to get that negative, because no matter what number we put there, we're going to get 2 squared, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the negative 1. We're going to end up getting a number that's positive. So the negative number is not going to work. And if you're still having trouble with that, go back and look at your notes. I think those are the end of the last day, or maybe the day before. So that is an extraneous solution. So the only answer here is x equals 3. Try the next one on your own and then take a look at what I've done here. All right, so I rewrote this as, now whenever you've got a log that doesn't have a base written, it's just a 10. They just don't write the 10. It's like when you don't write x to the first, because everyone just knows it's x to the first. Everyone knows the base of 10, or of log is regular log is 10, so they just don't write it. So we know the base is 10. So when I rewrite this as an exponential, it's 10 to the first power equals x squared plus 5x plus 4. All right, I factor. It works beautifully. My negative value is going to give me negative values here. I mean, I just threw negative 6 plus 1. That's going to be negative 5. That's not going to work. So I only have one answer. All right, I mean, it's going to get easier with time. You'll catch on. The next problem, we know, I'm going to have to stop in just a second. We know that this number has got to be positive, as we were just talking about. So that's got to be greater than 0. So x cannot be equal to negative 1, because if I put a negative 1 in here, I'm going to get a value that's equal to 0, right? That value is going to be greater than 0. So we go ahead and start right there, just knowing that. And the natural log has a base of e. To the x plus 1 squared equals 2. I'm going to stop and finish up in the next video.